Hey guys, this is Mr. Sal. We're going to look at 6.2 adding integers. Again, we're right in the middle of this epidemic, so hope everyone's safe out there and healthy, doing your social distancing or whatever it is, and keeping your family safe too. So let's go ahead and get started. Here's our objective: add integers with like signs, which we've kind of done before. So like signs, specifically with positive integers, right? So it says draw appropriate diagrams of colored counters to illustrate each sum, then find the sum translate into a mathematical expression. Now if we look back at the last section, remember when we had this oval thing right here, right? And then inside the oval, maybe there were some black dots like this, and maybe even some red ones like this here, right? Now if we looked at a problem like this, this would show a mathematical expression, as it turns out, because we have some positive, well, what do they call them? Counters in this one. And then we also have some negative counters on this one as well. So on this one, we would look and see, well, how many positive ones do we have? 1, 2, 3, 4, 5, 6, 7, 8 positive counters. And then how many negative ones? There's 6 of those. Now this is the same as adding these two together, right? So it's like saying we got 8 plus negative 6. Now just for the record, when we see that, we're probably going to see it more in parentheses like this. Then we get to the question of, well, how do we find the sum of this? Well, what happens is we got to identify the zero pairs, which means that I would find any zero pairs on this and just cancel them out. Now, since these are equal to 0, it means that we're going to make these phantom zeros. And whatever's left over is what the final answer would be, which in this case is 2. Because all I've got is how many of these counters? Well, I've got 2 of them, and then they are positive as well. So this is why the answer is 2, is because when we combine negatives with positives, there end up being a certain number of zero pairs, and then whatever's left over that can't zero pair out is what we're left with. And it has to be some number of positives. It could be some number of negatives. But for the example that we have, we're looking at only 2 positives that remain. So when we look at this example here at the bottom, right here, so it says you have $3, which is shown in this circle here, and then you have a $5 bill. So each of those $1 would be represented by another black dot. So how much do you have now? Again, we're just counting all of the black ones. There's no red counters on this one to cancel out any of the black ones. So we have 3 and 5, which equals 8. So we're going to do the same thing in this next problem. You have $12 in your pocket, all right? So again, we'll show this with a diagram, which would be very nice. Let's see, so something like this, right? Now it says you got $12 in your pocket, so I'm going to put 12 counters in this. So there's the 12 from the $12, right? And then your friend pays you $14 that they owe you. Now this would represent another 14 of these counters. So there's another 14. So then the question becomes, how much money do you have? Well, we started with $12. Then we added another $14 that was owed to us. And how much money would that be? Well, 12 and 14. You could count all the dots right there, and then you would find that there's 26. Now this one did ask how much money we have, so we do need to make sure that we label that. Now on this one it said find the sum. We showed the diagram and we translated it into the mathematical expression. The mathematical expression is 12 plus 14. So we've completed this problem. Now we can do this with negatives as well. Like we see over here, what do we got? You spend $2 on a vending machine, then you spend $5 on a sandwich. When we combine these, right, it's like having the -2 and -5, but we're adding these together because we're combining all of the negatives. And when we combine, that is addition. So right here where it says Sarah has -$8 in the bank. So again, let's just start with the diagram. We'll still write the math expression for this, but just starting with the diagram, right? So she's going to start with -$8 in the bank. 1, 2, 3, 4, 5, 6, 7, 8. Now again, I'm using red for negatives, black for positives. Then the bank adds an overdraft fee of $15. So I need 15 more of these, right? 8, 9, 10, 11, 12, 13, 14, 15. So what is the new balance of her bank account? So again, we go back and we look. How much did she start out with? Well, she had -$8 in the bank. But then the bank put an overdraft fee, which means it also is negative. Again, we usually put these in parentheses. And we're combining these negatives, which means that we're adding them together. Now again, this is the math expression. So what do we end up with on this one? How many negatives are there? So we know that there's only negatives. Just how many? 8 and 15 would be 23 of those negatives. So this would be the final answer on this one, -23. Of course, it is a bank account, so we'll show this as dollars. Now where you put that $sign really doesn't matter as long as it's on there, so that we know that we're dealing with dollars on this. Now I really like this counter method using the red and black counters. Some students really like it too, and I recommend doing it. You can even do it with big numbers, like if these numbers were huge. Then instead of using counters of 1, like you could make like maybe a square counter for tens or triangular ones for hundreds, and then just see what you can cancel out from there. So while it may seem impractical to use counters for big numbers, you can just change the shapes in order to represent bigger values if it were needed, if you really like that method. By the way, I do like it because it's a good visual to see exactly what's happening between the positives and negatives. And we'll see that. We did see it in the last section, but we'll see it in this unit as well. Now there's the second method, right? The next objective, add integers using a number line. One thing to remember with number lines, and we did kind of go over this in the last section, but I'm going to re-emphasize it in this section as well, is to the right, this is the positive direction. And I'm going to try to stay consistent with the colors on this, where black is positive, and then to the left is negative. All right. Now it doesn't really matter where it is on the number line. I know to the left of 0 is negative numbers, and to the right is positive numbers. But it really has more to do also with direction. So whenever you're adding negatives, you're going to the left on the number line. When you are adding positives, of course, you would still be going to the right on the number line. Now, if we can get the sense of direction on this accurately, then for the next section, hopefully this will be communicated a lot easier for us. Now, again, I like the counters, but the number line thing works if we can get the direction part of this down, because if I said I was subtracting a negative, then we get to think, well, what direction would I be going in? Or if I'm subtracting positives, what direction does that make me going? And again, we'll get into that more into the next section, which is subtracting in integers. So on these examples that they give us, right, so -1, again, on the number line, that's where we would start with. I wouldn't even really need this first loop or arc right there. I would just keep it starting at -1, and then it says it's adding -3. So what direction would this be negative 3? Well, it's to the left. How far? 1, 2, 3. So again, it would work the same thing on this second example. I would start at negative 5 right here. I don't really need this arc. And then it says that it's plus negative 2. So again, it's adding the negative. So what direction is the negative? It's to the left. 1, 2 spaces. So we end at negative 7. So it's going to work the same way with this example right here. I'm going to start at negative 2, which is right here. And then it says it's adding negative 4. So this negative really is the same as saying that I'm going to go to the left 4 units. So from negative 2, I'm going to go to the left 1, 2, 3, 4 units. And where do I end? I end at negative 6. So this equals negative 6 right there. So in this next example, I'm going to do the same thing. Now we got to fill this one in, right? So just to start out, we're going to start at negative 6. Now I'm going to put it farther to the right on this number line. And yes, 0 would be somewhere over here, right? Now I'm putting negative 6 farther to the right on this number line because I'm adding the negative 3 right here. So I know I'm going to have to go 3 spaces to the left. So I'm going to go to the left, 1, 2, 3 spaces. So I start here at negative 6. And then from there, since it's plus negative 3, I'm going to go to the left 3 units. So that's going to place me 1, 2, 3 units to the left, which would have been negative 7, negative 8, negative 9. And that would be our answer for adding negative 6 to negative 3. Alright, so there's another method for doing this which doesn't require any diagrams or number lines. So here's the rule, right? When adding numbers with the same sign, add the values but keep the sign. So if I were to look at this first example here in the bottom left, since these all have the same sign, right? They're all negatives. We got the negative 23, negative 14, and negative 38. I know that my total is going to be a negative value. Now, by doing that, I know that it's going to be a bigger negative value as we continue to add more negatives. So I'm just simply going to add all 3 of these together, 23, 14, and 38, just like I would a regular problem, knowing that my final answer is going to be negative. So what do we get out of this? 3 plus 4 plus 8, I get 15 on that one. Carry the 1, 1 plus 2 plus 1 plus 3, 7. So the answer to this, after adding all of them together, is not 75, it's negative 75. So this is what it means by when we're adding all numbers of the same sign, which in this case they're all negatives, just add the numbers together, keep the sign. And this would be true for positives, which we've seen already. So again, for these 2 examples, when I figure out my total, I know it's going to be negative, and then I simply take the 7 and the 5 and add them together, which would be 12. So my final answer, negative 12. Again, negative 18, negative 4, they have the same sign, so whatever the total is, it's going to be a negative value. And I can add those together. 18 and 4, bam, 22. So the final answer on this one, negative 22. Now once again, it shouldn't matter that the numbers are big, it just may take a little bit extra work, right? Once again, I know my answer is negative because I'm taking 2 negative values and add them together. So that would be 56 and 137 added together. 6 plus 7 is 13, carry the 1. 1 plus 5 plus 3 is 9, and then we have the 1 there. So the final answer on this one also, negative 193. Now that's pretty nice when all of the values are of the same sign. But what do we do when they're opposite signs? And we've kind of explained that already in this lesson. But when the signs are different, like they are in these examples, right? So this is negative 3 plus 5 right here. All I would do is look and see what values are going to zero out. So I take these three pairs and zero pair them, which means, again, that they're going to cancel out. Well, what are you left with? These two positive ones, so the answer is a positive 2. And the same thing would work on this next example. Just cross out any pairs that match and make them zero pairs, right? So after I cancel all these out, what am I left with? This negative 1 right here, which is the final answer. So again, I really like these these are called colored counters. I like the colored counters method because it's a nice visual to see exactly what's happening. Again, I'm using these blue lines to indicate that when I pair these up, it's a zero pair, which means they simply cancel away as 0. Now keep this in mind, in mathematics, when we cancel values out, it's not always 0. Just like we saw in the fractions unit, it is possible for values to cancel away as phantom 1s. It's more about values becoming phantom values, and you can have phantom 0s and phantom 1s. That's the only two values you can get phantom values for. So once you get phantom 1s and 0s, that's what we mean when we cancel values away. Now I'm just following the directions, right? It says, so we're going to draw an appropriate counter illustration for these examples. So like this first one, right? We'll just use the oval like they've been doing. And then we'll also find the sum and then translate into a mathematical expression, which we'll show. So first off, it says that James currently has $10 in his pocket. So again, I'm going to show 10 of these positive counters. There's 10 of them. But then it says he owes Daryl $17, right? Now I'm going to pair these up this way, just so it makes it easier to cancel them away. And there's 10, but we need 7 more, right? 1, 2, 3, 4, 5, 6. I guess I kind of ran out of space right there. 7. So I have 17 red counters, which are all negatives. Then I've got the 10 black ones, which are positive counters. So once again, I go and I see how many will cancel out. 1. Make that a little bit smaller. 2, 3, 4, 5, 6, 7, 8, 9, 10. Now, hopefully you guys are noticing a pattern at this point, right? Is whichever value is smaller between the positives and negatives, that's how many of the other one will cancel out. For example, there was less positive counters in this example than negatives. And all of them canceled out because there was less of them. So let's write the mathematical expression for this one. First, James currently had $10 in his pocket, so we show this as positive 10. But then he owes Daryl $17, so we show this as a negative 17. I'm going to put it in parentheses, and we add these two together. Well, what did we get in the end? So what does this equal? So again, I'm looking at all the red counters that were not canceled out, and how many is right there? There's 7 of them, but they're all negative, so it's a negative 7. And this would be his net balance, so yeah, we can tack on a nice dollar sign on this. Now I'll do the same thing for this next example. Michael's account balance is currently at negative $16. He deposits a check for $10 that he received from his grandma for his birthday. What is his new balance? So I have my 16 negative counters, which would represent 16 negative dollars. But then he deposits a check for $10 that he received from his grandma for his birthday. So I need 10 of these, right? And I'm just kind of starting from left going to the right. 10 of them, right? It doesn't really matter where you put them. Again, you could separate them, positives on left, negatives on right. It wouldn't matter. Just as long as you have some way to show that you're canceling these out. Now again, the test isn't going to require that you use this method. It's just a really good method. A lot of students like it. So again, if you're liking it, use the method, alright? So I'm going to find all my zero pairs. There's one. Sorry, I'll make that smaller there. There's another zero pair. How many zero pairs are there? 10. 10 zero pairs. So what are we left with on this one? We have all of these red counters right here. How many of them is there? 1, 2, 3, 4, 5, 6. 6 of these red and negative counters. Now again, this asks for is balance, so we're going to show this as dollars, but let's show the expression as well. Now on this one, it starts by describing his negative $16. So I'm going to show the negative 16. Now I don't need it in parentheses. I could put it in parentheses, but since it's the first term in this expression, I'm just going to keep it as negative 16. No parentheses. But then he deposits the check for $10. So we're going to take 10 positives. And yes, we are adding these together in order to get this negative $6 right there. So this would be the math expression for it. We've shown the answer with the label. Right now, his balance, he would still owe the bank, or someone, I guess, $6 at this point. Now on this next page, we're going to be using some number lines. Just remember, it's all about direction on these, especially when adding. So when we see a negative value that we're adding, we're going to the left. When we see a positive value that we are adding, then we're going to the right. So in this first example, of course, we're going to start at negative 1. Right, that's where we would start at, and then it's going positive 3, or it's adding 3 positives, which means it would be to the right, 1, 2, 3, and then you end at 2. Now the next example is a little bit different just because we started at a positive, which is at 2. And then we're adding 5, which means, again, it's to the left 5. So 1, 2, 3, 4, 5. And where you end, that is the final answer for these problems. So in this first example, I'm going to start at negative 4. But then it says to add 2. Now that 2 has a positive sign, but remember, we don't always show the positive sign for values. So since I'm adding 2, it means I'm going to go to the right 2 from negative 4. So I'm going to identify negative 4 on the number line right here. And I'm going to go to the right 2. So we'll show that on the diagram. To the right 1, 2. Now we didn't end in the positives, and that's okay. We ended at the negatives. But again, this would be the final answer for the problem. It equals negative 2. So on this next example, it says add 6 plus negative 3. We'll fill in the number line, and that's okay. Now I'm going to put 0 over here. Now it's not always necessary to show 0. It's just, I want to see it just so I know where I'm at on the number line. Specifically, right, we're starting at 6. 4, 5, and then 6 right here. So I am starting at 6, which is positive. And then I'm going to go to the left 3 spots because that's a negative 3. So I'm going to go to the left 3 from that negative 6. 1, 2, 3 to the left. And what value is that I end at? It's positive 3. So overall, this equals positive 3. So next up, when adding numbers with different signs, subtract the absolute values and keep the signs of the number with the largest absolute value. Now that's a little bit more explanation than I think we need, but it's technically correct. And here's what we mean by that, alright? So I've got a negative 14 and a positive 6. Now you could show the diagram for this. In fact, I still will on this one, alright? Just to kind of demonstrate exactly what's going on. So I'm going to start with 14 negatives, and then I'm going to add the 6 positives. Now, when we do this in the with the diagram like this, what would be the next step? Well, we would find all the 0 pairs, right? So that would be canceling these out. Well, canceling, what operation would represent canceling? Well, that's subtraction, as it turns out. So it really means that we're taking the two values and subtracting. But what do we know that we end up with on this one? We know that we end with a negative. So I put the negative in the total. So then what am I actually subtracting on this one? Well, I'm taking the 14 negatives and subtracting the 6 positive ones. Why am I subtracting? Again, I just want to reiterate this. We're subtracting because they're canceling each other out. It's just in the end, I know that I end up with more negatives, or I end up with negatives because I started with more negatives. 14 negatives is more negatives than 6 positives. Now, if there were more positives than negatives, then I know my answer is a positive, but I would still proceed with the subtraction. So what is 14 minus 6? 14 minus 6, 8. Now again, 8 is not the answer. Negative 8 is, though. So this would be considered the final answer on this one. But hopefully this demonstrates why we can use subtraction when we're combining different terms with different signs. And again, what we mean by signs is this one is negative and this one is positive. So as long as they're opposite signs, we can cancel them out with subtraction. So on this example, again, there's a few questions we should be asking about this. The first one is, are the signs opposites? Yes, they are. 1 is positive, the 6 is positive, and the 13 is negative. All right, well, that's okay. So I'm going to combine these together. Which one is there more of? Is there more positives or is there more negatives? In this case, there are more negatives, so I know my answer is a negative. All right, since the signs are opposites, I'm going to take the two values, 13 and 6, and I'm simply going to subtract them because, and yes, I'm using blue specifically in this case because those would be 0 pairs. How many 0 pairs would be in this example if we use the diagram? There'd be 6 of them because these 6 positives are going to cancel out 6 of the negatives. So I got 13 minus 6. My answer is negative. Negative what? 13 minus 6 is 3 and 3, so 7. And my final answer here is negative 7. So what do we do about an example like this one? So again, we ask the question, are the two signs different? Yes. I have a positive 8, and I've got a negative 5. They are different signs. Since they're different, I have to ask, do I have more of one than the other? Yes, I do. Which one is there more of? There's more positives in this example than there's negatives. So I know my answer is going to be positive, so I'm just going to put the sign there. Not that we need it for the answer. And I'm just going to say, well, how many 0 pairs would there be if we use the diagram? There'd be 5 of them because there's 5 negatives, which is less than the 8. So I'm really taking the 8 and 5, and I'm going to subtract those two values. Again, I'm using subtraction because I'm getting 0 pairs out of that. 8 minus 5 is 3. And again, I've already shown that the answer is positive. We don't really need that in the answer, so I'm only going to box in the 3. So 3 is the final answer for this problem. So it's the same process for these two, right? I got negative 17 and negative 25. They're opposite signs. So I know right away that I'm going to be using subtraction because we're going to have values that are zeroing out on this. Now, is there more positives or negatives? In this specific example, there's more positives. So I'm going to take the two values, the bigger one, and I'm going to subtract the smaller of the two values. 29 minus 17 is, well, let's see, 2 and 1, 12. Now again, the final answer is a positive 12. but I don't really need to show the positive sign in the answer. What about this next example, 56 plus negative 47? They're opposite signs. So again, I know with this problem, I know I'm subtracting the two values. Is there more positives or negatives? In this case, there's more positives. So I'm going to take the bigger number, which is 56, and I'm going to subtract the smaller number, which is the negative 47. I'm subtracting 47. I know my answer is positive. And what do I get out of that? 56 minus 47 is 9. So the final answer on this one is positive 9. Now on the second example, if we had drawn the diagram, how many zero pairs would there have been? That's right, there would have been 47 zero pairs, because these 47 negatives are canceling out 47 of these 56 positives, which again is why we're subtracting right here. Now when we see examples like this, we're simply following the order of operations. Now the nice thing about these is, and you can see even down here in the example, right, you can use the commutative property to switch these around, which is a nice strategy, and we're going to use two different strategies, which are kind of the same on both of these examples. So on this first example, I'm simply going to work from left to right. Now again, if you wanted to group all of the negatives together and all the positives and then combine them, that's fine too. But it doesn't really matter which way we do it. So I'm going to work from left to right, starting with negative 48 and negative 2. Now both of these have the same sign, so I know it's going to be negative, and then I would take 48 and add the 2, which is 50. So the sum of these two is negative 50. Now I'm going to write the whole expression as it is after I've simplified it from this first addition. And the next step here shows that I'm combining a negative 50 with a positive 71. Now again, this shows that there are more positives here than negatives. And since they are opposite signs, I'm going to subtract the two. I take the bigger number, 71, and subtract the smaller number, 50, to get 21. So that's going to end up being a positive 21. And now, after simplifying that far, I have only 3 terms, which makes this a very small, much smaller expression, right? So I'm going to add these two together. Again, they're opposite signs. I got a positive 21 and a negative 10. Now again, notice even for each of these steps, I'm not focusing on the 32 right now. Just like on this last step, I didn't focus on these 2 terms or these 3 for the first step. Moving from left to right means that we're only dealing with 2 values at a time, 2 terms at a time. So I'm going to take the 21 and the negative 10. Is there more positives or negatives in this case? Well, there's more positives because 21 is bigger than negative 10. So I know the answer, the sum of these two, is going to be a positive value. And I'm going to take the 21 and simply subtract the 10, which is 11. So after subtracting those two, I got positive 11. And then now I've simplified this into 2 separate terms, which is going to be very easy to combine because they're both positive. And 11 plus 32 is 43. So the final answer on this one is 43. We added all the terms moving from left to right. Now in this next example, we're going to use the commutative property of addition to move these values around. And this would be considered the second strategy. Now I start with the positives first. I got the positive 9, the positive 3, and the positive 2. When I add all of these together, I get 9 plus 3 plus 2 is 14. Then I look at my negatives. I got a negative 4 and a negative 20, which when I combine, I get, so again we are adding these together, I get a negative 24, which we are adding these two together. So I got 14 plus negative 24. When I look to combine these two, is there more positives or negatives? Well, there's more negatives, so I know my answer is going to be negative, which then allows me to take the bigger number, 24, and subtract the smaller one, 14, which is 10. So the final answer here is negative 10. Don't forget the negative on that part. So from this last example, we should be able to add any number of positive and negative terms together, or positive and negative values, whichever you want to say. But hopefully this has been helpful for you guys out. You guys should be able to do the homework from here. So thanks for watching. If you guys got questions, let me know. And we'll see you guys in the next video.